Hi everyone, welcome. In this video, we're going to discuss about the graphical meaning of differentiation, which is the slope of the curve. So here we have two panels. On the top, you have blue color graph, which is the function f of x. You can plot it the way you want. So you can curve up, curve down, depending on the way you want it. And this is a control to do that. You can reduce the width of the graph. You can reduce the width of the graph, or maybe you can increase the width of the graph like this. That's one control we have. The other control is to plot these flat shaped graphs. You can make it flat shaped graph, and again you can reduce and increase. Reduce the width of it, you can make it like this. That's one possibility. And then another possibility is turning the graph up and down. That's another control you have. The fourth control is to slide it up and down, using which you can plot f of x qualitatively the way you want it. The moment you plot f of x, which is a blue color graph, automatically that f dash of x will be given by the simulation. You can change the control, that magnification, the scaling of it, you can change it so that you can see the entire graph. The f dash of x is shown here. So what you have in your control is plotting f of x, and f dash of x will be given by the simulator automatically. So first let us take the straight graph. Okay, consider the straight graph. When you have a straight graph, you see that f dash of x is 0. And here we see that it is parallel to x-axis. And it is passing through origin. Now suppose I move the graph up or down, you see that the slope is not going to change. So when a straight line is parallel to x-axis, wherever it is located, maybe on x-axis or above x-axis or below x-axis, f dash of x will be 0, which is equal to slope of the graph. So that is one point that you need to understand it. So to compare it with the slope of the tangent, you can mention the tangent over there. You see tangent is horizontal at any point, and that is where slope is 0. When the slope is 0, f dash of x is also 0 there. Now you can move it up and down. Wherever you move it, you see that the tangent maintains its orientation, horizontal. So the slope is 0, and that is why f dash of x will also be 0 only. So f dash of x equal to slope of the tangent. That's the point that we want to bring it to using this simulation. Okay, now that the graph is parallel to x-axis, we have it like this. How about when the graph is making certain angle? Let's say a certain angle it is making, it is not parallel to x-axis, maybe upward sloping graph. You see, as it is becoming upward sloping, right? I can show the tangent over there. You see, tangent makes an angle. You see, the tangent is upward sloping, and so the slope is positive, and f dash of x is positive. And you see that the f dash of x is same everywhere. And again, f dash of x is a constant function. So for the straight line, slope is constant, and that is why f dash of x is constant function. When it is horizontal, it will have 0 value, f dash of x everywhere. When it is upward sloping, it will have positive value and the same value everywhere. When it is downward sloping, f dash of x is negative because slope is negative, because tangent is downward sloping. So straight line, it is very easy to play around with. For a straight line, slope is constant, and so f dash of x will be a constant function. If it is upward sloping, positive value, downward sloping, negative value. That's what you can observe it very easily. Okay, that's one aspect. We can look at it. Now let us plot curved graphs, flat shaped curved graphs. Let us plot, see how it goes. Let's make it this way, and then make it up, make it down. And now to see the entire graph of f dash of x, just to minimize the scale, you can see it. So now let us plot it, see how it goes. At this point at origin, tangent is parallel to x-axis approximately. So that means it is having 0 slope. Because slope is 0, you can see that slope of the tangent is 0, f dash of x is also 0. As you move it to the other side, you see that the tangent becomes downward sloping. Whenever it is got downward sloping, you see that the slope is negative, and so f dash of x is going to be negative in this region. And then as you come further forward, you see that it has turned back parallel to positive x-axis. During this interval, you see that the tangent is parallel to x-axis, which means that it has got zero slope. Whenever it has got zero slope, you see that f dash of x will be zero in this region. And then as you move further, you see that the tangent turns in upward direction. Whenever you have upward sloping for the tangent, you see that the slope is positive, and you see that f dash of x will be positive in this region. So f dash of x is positive and the slope is positive. Now you see in this region, you see that the slope of the tangent is 0 because it is parallel to x-axis. Slope of the tangent is 0, f dash of x is 0. Again, as you move further, tangent has become upward sloping and the slope has become positive here, and f dash of x has become positive. Whenever it turns back again, slope is 0. In this region, slope is 0, and that means f dash of x will be 0. And then you can proceed further. In this region, it is downward sloping. Downward sloping, whenever you have it, you see that f dash of x is negative because slope is negative. So from here you can understand that f dash of x, which is a derivative of the function f of x, is equal to slope of the tangent. That is a graphical meaning of f dash of x. That's what I want to bring to your understanding in this particular video. Okay, now you can look at other graphs, maybe curved graphs. You can make it and make it interesting like that and so on. So you can make any kind of shape of it, you see that. So you can turn it around as it moves. You see how the tangent is oscillating back and forth as you are moving it like that. So simultaneously watch here and watch this and also this. These three things you focus on: the rotation of this, the value of this, which is equal to the value here. So I move it slowly and observe it. Now it is 0, turn up, positive value, and again down, horizontal, parallel to x-axis meaning 0 slope. Now turn up, again turn back to horizontal, turn down now, negative slope. So whenever it becomes horizontal, somewhere over here it will become horizontal, meaning there the slope is 0 there. And then again it turns up back. So this is how the graph will change. The basic idea here is that slope of the tangent drawn to the graph is equal to the f dash of x. This is a point I wanted to bring here. Alright, now that we understand, how will the tangent slope change as you move it up and down? Suppose I move the graph up and down. You see, as you move the graph up and down, slope is not going to change and the value of the function is also not going to change. Anyway, you can keep it. Somewhere here you can keep it. And you see, when you move the graph up and down, the value of f dash of x is not going to change. It is constant. The value is constant. But instead of sliding it, if you rotate it, it is going to affect. You see that now. As you go move it up and down, you see that f dash of x is changing, and you see the entire f dash of x graph is going to go up. Turn it down, it is going to come down. So rotation in f of x causes translation in f dash of x. A rotation in f of x causes translation in f dash of x. When you rotate it in anti-clockwise direction, you see that the f dash of x is moving upwards. That is a graphical meaning of the function. This particular video I wanted to bring to your notice. So I hope you understood that. Thank you very much for watching. Until next time, bye.